Hello everyone, my name is Krisztian Fekete and I will show you how you can build an eBPF based oomkiller-exporter in 5 minutes. I'm currently working at solo.io and I was at LastPass before that. Let's start with a very quick summary of what oomkills are. As you may have already known, the origins of the oomkills dates back to the old days of Linux. When your machine, that can be a bare metal machine, virtual machine, or a node in the Kubernetes world is running low on memory, older pages of memory will be reclaimed. If this is not possible, a function called out of memory will be called with a single task, avoid running out of memory. This will first check the available swap, then check when was the first attempt to free memory pages. Maybe even wait for pending IO operations to finish. Before hope is lost, it will have to kill a processor. In the case of Kubernetes, the basics mentioned above still apply, but now you can leverage quality of service classes for your plots. For example, guaranteed, burstable, and best effort. Behind the scenes, these are translated to a score, and that score can help determine which process should be killed. In most of the cases, pod gets oomkilled if it reaches the limits of its containers. So yes, you should always configure these, or the node of the pod gets overcommitted. Monitoring these events is crucial for reliability, but catching them is not trivial. Fortunately, eBPF can help. We will take an existing oomkill detector script, then use Bumblebee to deploy it in a Kubernetes cluster and expose these events that it captures as Prometheus metrics. Okay, so let's see this in action. We will use the BCC repository's oomkill.bpf.c example. That's all the logic that you need to capture the oomkill events. And with this approach, you would need to use another C file to handle the lifecycle of the BPF code, but with Bumblebee you won't need this. Let's take a look at the differences between the upstream oomkill logic and our BPF logic. First, we have abstract, that is currently changed here. Here we are essentially have a map that can be written from both kernel and userland, and we are migrating it from per buffer to ring buffer. We have to do this because Bumblebee currently only supports ring buffer and hash map, but this is currently a best practice for fairly new kernel versions because ring buffer saw suboptimal performance in tedious tasks during BPF development. Then secondly, we are changing our core BPF logic, which is basically being triggered by every oomkill process kernel probe. We are already enjoying the benefits of the previous migration as we can leverage the reserve commit API of ring buffer. With this approach, you can reserve the space for the data early on and avoid inefficient use of memory, because if you could reserve the memory for your sample, the commit to user space cannot fail. We can use Bumblebee to build this into an image. I have the BE CLI up and running here. The comments are similar to what we have with Docker. To build, you can use BE build to build this logic into an OCI image and push it into a local or remote registry. I have one running locally, so I will use that. After you build it, you can push it to this registry, and after that you can run it. If you can successfully run it, that means that it passed the kernel verifier, so your code should be safe in the kernel. I deployed the CLI package as a daemon set on every node. I have 3 nodes in this Kubernetes cluster, and Bumblebee is running on all of that. And I also have a memory leaker program that is currently in crash rollback because of the oomkill sessions. If you check the Prometheus UI, we can already see that we have this metric exposed, and we have the same labels that we used for our struct in the BPF code. We are currently working on tighter Kubernetes integration. We will have probes like this to deploy your custom BPF logic, and we will also have better correlation to pods for your actual processes. So as you can see, it's this easy to take an existing eBPF script and package it with Bumblebee and expose the output Prometheus metrics. The possibilities are almost endless because now you have an easy way to get familiar with BPF and package your logic as OCI images. Thank you for joining me today, and I'm available on Slack for Q&A.